All right, guys, welcome back. Here is our math lesson for today. We've got some notes on multiples and factors, and so I'm going to get started. If you have any questions or any concerns about multiples and factors, please make sure you let me know prior to tomorrow's test. I don't want anyone feeling like they are kind of left in the dark. That's not our goal here. So here's what we're going to do. We're going to talk about multiples and factors. You played games with both of these things last week, but now we're going to actually spend the time to define them. Like that velociraptor, I brought you in, and then I pounced with actual math. So we're going to start with factors because of the fact that that's where we started last week. So if you'll start down here on your notes, factors, it says there are a blank of factors, which means limited number. So the words we're going to look here are fixed number. So there are fixed factors. We talk about alliteration like we did last week in our literary device study. There are fixed factors that might help you remember how many factors or what factors are. That means there's a limited number of factors. Factors are something that there are certain number and that's it. As opposed to, and I'm going to switch to blue for multiples, there are a multitude of multiples. I love alliteration. It really helps me to remember things. There are a multitude of multiples, meaning there are infinitely many. I could multiply the number 2 multiple times. I can multiply it by any other number in the number system and still come up with a multiple of 2. So there are a multitude of multiples while there are a fixed number of factors. So in looking at the number 16, as is here in the center, when I'm thinking of factors of 16, I'm going to think of them in pairs. So we have the very obvious pair, which is 1 times 16. That is the obvious pair of numbers. So 1 times 16, and each of these is a factor of 16. Remember that factor pairs are basically just the two numbers that multiply together to get that number that's up there above. Next, I look at the fact that it ends in a 6. Since it ends in a 6, it is even and therefore divisible by our only even prime number, 2. 2 times 8 will give me 16. And then I'm going to think, okay, what else might go into the number 16? Well, 6 plus 1 is 7. So I know it's not divisible by 3. If I look at 4, I go, oh, it is divisible by 4. So I know that 4, and then I have to think, okay, 4 times what gives me 16? Well, 4 times 4. I always remember this particular multiplication fact as you have to be 16 years old to drive a 4x4. So I have 1, 2, 3, 4, 5 factors for 16. We do not repeat the number 4, so we don't call it 6. There are 5 factors of 16. So being that there are 5 factors of 16, I'm going to turn my paper to the side since I do not yet have it taped down. I'm going to turn my paper to the side, and I know it says name right here, but it's in your interactive notebook, so I'm not going to worry about the name. I am going to remind myself of the following. A number with an odd number of factors is a perfect square. It is a perfect square, meaning that I have one factor that multiplied by itself will give me the number that the product, in this case, 16. So 4 times 4 will give me 16. And there are an infinite number of squared numbers because I can do 2 times 2. That gives me 4 as a product. That is a squared number. I could choose the number 11. 11 times 11 is 121. 121 is a squared number. So you could keep going up and multiplying any number in the numeric system by itself, and it will provide for you a square number. Knowing the squared numbers up to 100 is usually pretty effective. Later in life, you might want to know a few more than that, but ultimately, as long as you understand how to identify a square number and how to create a square number, you will be fine. So, here we have factors. Factors, over here on this side, says factors come in pairs. And I'm going to write the word pairs. And then, just for fun, I have a green pen here. I'm going to draw myself a pair. Nice little play on words. We know that this is a homophone. It's clearly spelled differently, but it is fun. They come in pairs. And I guess if we're talking about pairs being a couple, we're going to draw 2 pairs. I just look like I colored in the number 8 there. All right, so factors come in pairs, and you can color this to whatever way you want to. That's entirely up to you. You can do fancy writing if you'd like. Again, it's up to you. So factors are fixed. There are fixed factors. I love alliteration. It really does help us to remember things. So now I'm going to switch over to that blue that I was using before. And we're going to talk about multiples. So there are a multitude of multiples, meaning they're infinitely many. Numbers only count as factors or multiples when you multiply or divide by integers. Here's the key that I know some of you were concerned about when it comes to square numbers and things like that. We are not talking about fractions. We are not talking about fractions, and we are not talking about decimals. Okay, we are just talking about whole number integers. I apologize, I'm going to go ahead and reset this so that it's a little clearer. There you go. Not fractions, not decimals, whole numbers. Now, on a test, you might be asked to come up with 5 factors of a number. Make it easy on yourself, guys. Do the first 5 factors. Or, I'm sorry, not factors. I apologize. You might be asked to come up with the first 5 multiples or 5 multiples of a number. Make it easy on yourself. Come up with the first 5. So if I multiply 16 by 1, I'm going to get 16. 16 is a multiple of 16 because it's 16 times 1. If I multiply by 2, I'm going to get 32. If I multiply by 3, I'm going to get 48. If I multiply by 4, I'm going to get 64. And if I multiply by 5, I will get 80. Again, if you're asked to come up with multiples, do yourself a favor, come up with the first 5. It's just going to be easier for you. 1, 2, 3, 4, and 5. In addition, come up with 5 consecutive numbers. If you choose not to do 1, but you choose to start at 2 or 3, I would go in order. So that way, if you're a little more uncomfortable with multiplication, you can just add the number 16 to the last number. Now, there are obvious ones you could do as well. You could say, okay, well, 16 times 10, I'm just going to add a 0 to the end. 160 is a multiple. I could multiply it by 1,000. 1,600 is a multiple of 16. Again, it's entirely up to you, but I highly suggest the first 5. So, to recap, to find multiples, let's look at this. Hold on. Give me just a moment. Let me find some other color that I've got going on in here. Why do I have crayons in my little box? So all of these examples are for the number 16. So please don't worry if you feel like they don't fit any other numbers. These are all specifically for the number 16. All right. So to find multiples, we multiply. For me, the fact that multiple sounds like multiply helps me remember that we multiply up. To find factors, we do the opposite of multiply, and we divide. I have heard factors as when you are doing factors, you are a factor ninja. If you've ever played the Fruit Ninja game where you have to cut up fruit, remember that in factors, if you're a factor ninja, you're cutting up numbers. And I could keep going if I wanted to. Times 6 would be 96. Times 7 would be 112. I could keep going, like I said, to all the way out to 10, where you'd get 160, and so on and so forth. Okay, so we're going to practice this really quickly. We're going to list all factors and the first 4 multiples of 72. So, first of all, we have 2 assignments here. We're going to list the factors of 72 and the first 4 multiples of 72. So, let's talk factors. Factors. I always overestimate how much room I have. Factors. So the factors of 72 are, and you can write them in pairs if that makes it easier for you. I highly, highly, highly recommend it. If you give it to me in pairs instead of a list of consecutive numbers, that is fine, because this is a good way to double check that you have all of the numbers. So I know that the factor pair for 72 is 1 and 72. It is an even number, so 2 is a factor of 72. Now the question is, what is its partner? Well, in this case, it's 36. 7 plus 2 is 9, so I know it's divisible by 3. So I have to think about that. What is the answer there? Well, 72 divided by 3 is 24. I know that because a 24-hour period is 3 of them with 72 hours. It is divisible by 4, 18 times. 2 and 3 are factors of 72. Therefore, 6 is also a factor. 6 times 9 is going to give you 72. I don't know why I said that. That is really not correct. And I don't think I have white out in my room with me. Please ignore my ineffective writing there. This is 6 times 12. I was a step ahead of myself because 72 is not divisible by 7, but it is divisible by 8. And this time, the factor pair is 9. So, I know that I'm at the end of my factor pairs. Here's the part you need to think about. How do I know when I've got all of the factors? When my factor pairs start to repeat, I've come to the end of the line. In this case, I got up to 8. The next number would be 9, but 9 is already represented in my factor pairs. So I know that I have reached all of the factors of 72. They are 1, 2, 3, 4, 6, 8, 9, 12, 18, 24, 36, and 72. And I apologize for the mistake right here. Now let's talk about multiples. What are the first 4 multiples of 72? And these are some actually pretty big numbers here, but we know that there's 72 times 1, which is 72. 72 times 4 is 144. 72 times 3 is 216. And 72 times 4 is 288. Again, I could keep going. That's why there are a multitude of multiples. So 72, 144, 216, 288. When we multiply, we go up. Therefore, multiples are multiplied, and there are a multitude of them. Fixed factors, there is a fixed number of factors, and we divide. We flay them. Ooh, that's a good thought. We flay factors. Flay means to cut open. So we flay numbers to get the fixed number of factors. Love alliteration. It's fantastic. Now it's asking us to specifically come up with the factors of 45. We did that already this morning when we were discussing the assignment you had last week. They are 1 and 45. Again, I'm going to go through the process. It ends in a 5, not an even number, therefore it's not divisible by 2. 4 plus 5 is 9, so it must be divisible by 3. 3 times 15 will give me 45. And then last but not least, not 4, 5 goes into 45 9 times. 2 is not a factor, therefore 6 is not a factor. 7, I know we have 42 and 49, so it goes right around 45. 8 is also not a factor of 45. 9 is a factor of 45, but it's already listed here, which means I've gotten to the end of my factor list. So again, I'm going to go ahead and rewrite them in order. 1, 3, 5, 9, 15, and 45. And then in this last box, it wants us to list 5 multiples of 8. Notice it doesn't say which 5. It doesn't say the first 5. But I am all about ease. So I'm going to go ahead and do the first 5. So our first 5 are 8. Then we have 16, which is the number we've been working with up there. Then after that, we have 24. That's 8 times 3. 8 times 4 is 32. And our fifth and final multiple in this particular case is 40. And again, I could keep on going because there's an infinite number of multiples. All right, guys, make sure that you remember multiples and factors, prime numbers versus composites, and square numbers. Those are the 5 things on which you will be quizzed tomorrow. All right, everyone. Thank you so very much for your time today, and I hope that everything will go smoothly for you for the rest of the day. Now I have to just figure out how to stop screencastifying on this particular, no, don't look at that, on this, on my, okay.